Alright, I'm going to talk to you about probability, and what I want you to realize is that there's two types of probability. There's theoretical probability and there is experimental probability. Theoretical probability is in theory, and you can see that from the word, it doesn't say theory, but you get the idea that in theory, what do you think is going to happen? Um, Experimental probability is based on what actually happens. And if you think about it, you've got the word experiment there. So if you actually perform an experiment, and I'm talking about like flipping a coin, spinning a spinner, rolling a number cube, those kinds of experiments, experimental probability is based on what really happened. Now, also what I want you to realize is that um, theoretical probability and experimental probability are different. They're different and that you're going to have different answers. But the idea is the more that you perform the experiment, the closer the experimental probability gets to the theoretical probability. And I'll elaborate more on that in a second, okay? But just really, I want you to realize that there's two different types of probability, theoretical probability and experimental probability. So probability can be written as a fraction, a decimal, or as a percent. And that's because the fraction 1/2 is the same thing as 0.5, which is the same thing as 50%. They all mean the same thing, they're just written different ways. So because of that, you can write probability any of those three ways. Now the examples I'm going to give you today, I'm going to be writing them as a fraction. It does not make a difference to me how you write your answers unless the directions specifically say to write it as a decimal, percent, or as a fraction. Then of course you need to write it that way, but if it doesn't say it, you're going to find that a fraction is probably the easiest way to write it, okay? Now the way we write probability is it's written so that what you're looking for is over the number of outcomes. So let's use a dice as an example, or a number cube, or a die. Okay. When I look at a standard number cube or a standard die, there are 6 outcomes. Outcomes is what can happen. And what I mean by that is I can roll a 1, a 2, a 3, a 4, a 5, or a 6. There's 6 different outcomes when I roll a number cube. There's 6 different things that can happen. And so if I said, what is the probability of rolling a 3? This is just a short abbreviated way of saying probability of a 3. Okay, so I look at my outcomes. The bottom number is how many outcomes there are. The top number is how many out of my outcomes satisfy what I'm looking for. So out of my 6 outcomes, I see 1, 3, so the probability is 1/6 that I'm going to roll a 3. The probability that I'm going to roll an even number. Again, I have 6 outcomes on a standard number cube. Out of these 6 outcomes, I have 1, 2, 3 numbers that are even. So because I have 3 numbers that are even out of 6, there's a 3 out of 6 chance that I'm going to roll an even number on a number cube. However, because we always simplify fractions, we need to simplify this. So we're going to simplify 3/6 to be 1/2. So that means that the probability of rolling an even number is 1/2. Now, what if I asked you the probability of rolling an 8? Again, you want to look at your outcomes. I have 6 outcomes. Out of those 6 outcomes, how many 8s are there? There aren't any outcomes. There aren't any 6s, I'm sorry. I apologize. There are not any 8s. So it's going to be 0 out of 6, which is the same thing as 0. So there's a 0% chance or 0 chance that I'm going to roll an 8. Alright, let's look at a coin. Okay, the outcomes when I flip a coin, it can either land on heads or it can land on tails. So if I said, okay, what's the probability of landing on heads? Again, the bottom number is the number of outcomes that there are. There's 2 outcomes. The top number is the number of outcomes that satisfy what I'm looking for, which in this case is heads. So it's going to be 1 out of 2, and this cannot be simplified. It's already simplified. What if I said, what's the probability of flipping a coin and it landing on heads or tails? Again, there are 2 outcomes when I flip a coin. And when I look at those, there's 2 times that there's 2 outcomes that are either head or tails. So you would say 2 out of 2, which is just the same thing as 1 whole or 100%. So it's guaranteed that if I flip a coin, it's going to land on heads or tails. What if I say, what's the probability of the coin not landing on head or tails? So not heads and not tails. Again, there are two outcomes. I don't have, neither one of my outcomes are not heads or not tails. They're both a head. You got a head and a tail there. So there's 0 outcomes that are not heads or not tails. So that means there's a 0% chance that you're going to pick something that's not heads or not tails. So you have to really be sure to look at your wording. What if I said, what's the probability of flipping a coin and it landing on heads and tails? Again, there are 2 outcomes, but out of those 2 outcomes, not one of them is heads and tails. It is impossible that I can flip a coin and it land on both heads and tails. Now, I'm not doing the coulda, shoulda, wouldas, what ifs, what if it lands on its side. We're not doing all that. So we're just going to say that it's 0. So there's a 0 out of 2 chance that it's going to land on both heads and tails. These are all theoretical probability problems, meaning that half the time, if I flip a coin 10 times, let me write this. If I flip a coin, let's say I've got heads and I have tails. I can flip a coin 10 times and it land on heads 7 times and land on tails 3 times. This is not the same thing as 1/2. It's expected in theory that 5 times it would land on heads and that 5 times it would land on tails. That's in theory what should happen, but in theory what should happen is not always what happens. This right here is considered experimental data, because if I was to use this data to predict, I would predict that it's going to land on heads again, even though there's still a 1/2 chance that it's going to land on heads. The idea here is that the more times you perform an experiment, the closer the experimental probability gets to theoretical probability. So yes, I only flipped this 10 times and these are my results. But if I flip this coin 90 more times for a total of 100 times, it's going to get closer to where it evens out, so that 50 times it's heads and 50 times its tails. And it may not be right at 50, you may have 49 and 51, but I guarantee if I flip it 1,000 times, it's going to get even closer. I mean, it's just going to get closer. Experimental probability gets closer to theoretical probability the more times you perform the experiment. Sorry, I'm getting a little tongue-tied here. So let me show you an example of that. Here is a spinner, and this is a special kind of spinner in that I can tap it and it spins. And so I'm just going to keep track of what happens. So we've got green, red, orange, and blue. That's not a B. Sorry. All right, so it landed on green one time. Actually, I'm going to make this smaller so that I can fit more in here. Okay, so it landed on green one time. So I'm going to flip it again. And it's going to land on orange. And you would expect, in theory, that 1/4 of the time it lands on green, 1/4 of the time that it lands on red, 1/4 of the time it lands on orange, and 1/4 of the time that it lands on blue. But that's not necessarily what's going to happen here. All right, so then it landed on green. And we got an orange. Oops, I didn't do it right, sorry. And there's our blue. Let's do it one more time and then we'll see what it's like. And we got blue. So far, just out of 12 times, we've got 3 out of 12, which is 1/4 green, 2 out of 12, which is 1/6 red, 4 out of 12, which is 1/3 orange, and 3 out of 12, which is 1/4 blue. So the green, it hasn't landed on the green as much. But if I keep spinning it, it's going to get closer to where The green and the blue will probably stay about the same, but the red's it's gonna land on red more, and it's gonna land on orange just a little bit less to where it evens out. So let's see if we do this. I said that, and then watch what happened. It landed on an orange. Spin that one again. I don't know what side that landed on. You can see right here how it's evening out, even just since I've been doing it. The spinner's not helping me prove the theory, is it? Oh, that was not green, that was red. Sorry. Red. It's red barely, but that's red. You can see how it starts like it was kind of like blue was kind of back, but now it's kind of catching up with the rest. And but anyway, I'm going to stop because I know this is slow. But you get the idea that it starts to all kind of balance out in the end, and that's what happens. The theoretical probability is that they would all be about even. But the more times you perform the experiment, the closer it gets to actually evening out so that it is more even.